A charged particle is situated in a field of force. Deduce the nature of the force field, magnetic, electric, or gravitational, when the force on the particle is along the direction of the field regardless of its charge and velocity. It's about gravitational. Why? Because definitely it is independent of charge and velocity, and we know that gravitational force is always attraction between what 2-point masses. Force, and force it's what it's mg, where g it's the gravitational field strength, and since mass is always positive, so vector is a positive constant multiplied by another vector, so this vector g will be always in the same direction as force, and the direction of force or the gravitational field strength, it's always in the direction of the line which connects the centers of mass of two objects. So it's about gravitational. The next is independent of the velocity of the particle but depends on its charge. So it's about the electric force. Why? Because you know formula that the electric force is what it's charge multiplied by the electric field strength, and it is independent of the velocity but depends on its charge, and depends on the velocity of the particle and its charge. It's about the magnetic force, or it's called the Lorentz force, or force on the moving charged particle in the magnetic field, and force is charge, velocity, magnetic field strength, and in general sine of the angle between V and B. And you can see that it depends on both charge and velocity of the particle, so it's about magnetic. An electron is accelerated from rest in vacuum through a potential difference of 2.1 kilovolts. Deduce the final speed of the electron. And when an electron is accelerated in the region where there is a potential difference, it gains electric potential energy or work done on this electron, and this energy is transferred into kinetic energy of this electron, and law of conservation of energy is equal to gaining electric potential energy, its charge multiplied by the potential difference, and for electron it's elementary charge, so we can write elementary charge times potential difference. V or delta V doesn't matter. This formula is given in data booklet, and it is equal to mv squared over 2. And just solve for V, this V, so it's V square root 2eV over m, and it is equal to 2 times 1.6 times 10 to negative 19, 2100 divided by 9.1 times 10 to negative 31. It's mass of the electron. It's given in a data booklet, and it is equal to 2.7 times 10 to the power of 7 meters per second to 2 significant figures as required. The next. An electron in B then enters a region of uniform electric field between two conducting horizontal metal plates as shown below. Uniform, it means something like constant, and field lines are parallel and in the same direction and equally spaced between plates. On the diagram above, draw an arrow at P to show the direction of the force due to the electric field acting on the electron. It is given potential on the first and the second plates, and for high level you should know the next, that you should know potential for standard level, potential not required. And if we say about potential, so potential decreases in direction of electric field. So we can see that potential decreases downwards, so electric field is downwards. And it means, and we know that field from plus to minus, so this plate is positively charged and this is negatively charged. For standard level, there will be a given polarity or direction of the field. Or you may remember that, and hence electron is moving in what direction? To plus, so upwards. Or you may remember that electron is moving in direction of increasing potential. So force of this electron is upwards. Electric force is upwards. And it will have a parabolic path. So, and the situation is absolutely the same as free fall, but with another acceleration. For free fall is g 9.8. For this situation there will be another acceleration, but you may apply you can apply so that formulas because acceleration is constant. And acceleration is constant because uniform constant electric field. Force is constant within plates. The next, calculate the force on the electron due to the electric field. So force is charge, it's elementary charge for the electron times electric field strength, and electric field strength is potential difference divided by distance between plates. This distance. So it just becomes 1.6 times 10 to negative 19. 95 minus 0 is 95, divided by, it must be in meters, so 0.022 meters. And when you just calculate it, and it becomes 6.9 times 10 to negative 16 newtons, to two significant figures. Next, determines the time of flight between the plates. And actually acceleration is it's what it just force divided by mass, and they both are vectors. Mass is positive, so acceleration is also upwards on this electron. And you can see that it's velocity and it has only horizontal component. So how to find time? We can consider, so that formula, what formula? Displacement is ut plus at squared over 2. Notice that all values are vectors, and consider this equation in horizontal components or in projection on x-axis, which is horizontal axis. And we can see that horizontal distance traveled, and hence displacement is plus. We consider x to be to the right, so displacement is plus 12 centimeters, so 0.12 meters is equal to horizontal component of the initial velocity. It's this actually, and it's 2.7 times 10 to the power of 7. And time, and acceleration is perpendicular to our horizontal axis, or horizontal component of the acceleration is 0, so it's just uniform motion, or motion with constant speed in horizontal direction. It's absolutely the same as a ball thrown with horizontal speeds from some height, and it moves under the gravity. Absolutely the same. And hence time is 0.12 divided by 2.7 times 10 to the power of 7, and is 4.4 seconds. Not 2 point, not just 2 point, not just 4.4, because it's 0.12 divided by 2.7. It's 4.4, and here the -2 minus 7, it's minus 9 seconds. Okay, next, determine the vertical distance moved. So it has some parabolic path, and we need actually vertical displacement. And we can apply the same formula, but in projection on y-axis. Let the y-axis be positive, direction to be upwards. So displacement required, we calculate it, is ut, its vertical component of the initial velocity, and it's 0, plus acceleration is just force divided by mass. Force is 6.9 times 10 to negative 16 divided by the mass of the electron, 9.1 times 10 to negative 31, and time squared 4.4 times 10 to negative 9 squared, and this 2, and it becomes 7.3 times 10 to negative 3 meters. The next, suggest why gravitational effects were not considered when calculating the deflection of the electron. Let's calculate the gravitational force mg. It's 9.1 times 10 to negative 31 times g, and you can see that it's approximately 10 to negative 30, 10 to negative 29 newtons, and you can see that what the electric field is 10 to negative 16. So we can say that the gravitational force is very small in comparison with electromagnetic force, so it is negligible. It is not taken into account. The next, if in a mass spectrometer electric and magnetic fields are used to select charged particles of one particular speed, a uniform magnetic field is applied in the region between the plates such that the electron passes between the plates without being deviated. For this magnetic field, state and explain its direction and determine its magnitude. So there is electric field upwards, and the electron to be not deflected, there must be balancing force of the same magnitude, which is downwards, so that net force is 0 and it is moving in a straight line. And it's it's the Lorentz force. We know magnitude. It's charge, velocity, b, and sine of the angle between v and b. And what about direction? To find the direction, we use Fleming's rule, or I use the left hand palm rule or the right hand palm rule. For a wire or positively charged particle, for example proton, we use left hand palm rule. For negatively charged particle, for example electron, we use the right hand palm rule. How it works here, and actually, so it's it's electron, so we use First of all, the magnetic force must be downwards. Then, to find the force on the moving charged particle in the magnetic field, it's electron, so it's a negatively charged particle. So we using the right hand palm rule, or you may use the Fleming's rule. How it works? You take the right hand, and 4 fingers must be in direction of the velocity and thumb in direction of the force, and its right hand, and vector B, or magnetic field, must enter the palm. And it appears, if it's a right hand, so B enters the palm, so palm is here, so B enters the palm. So B, or magnetic field, is into the page. So magnetic field is into the page. For a proton or a wire, for positively charged particle, absolutely the same, but we use the left hand, and also always for all rules, vector B, or magnetic field, enters the palm, inner part of the hand, and 4 fingers in direction of the velocity, and thumb is in direction of the force. For wire, 4 fingers in direction of the current instead of velocity, but we use the left hand palm rule also for the wire in magnetic field. It's called the ampere force on the wire in magnetic field. So, and magnitude, for magnitude, we know that electric force, it's what? It's the 6.9 times 10 to negative 16, and should be balanced by what? B, and its elementary charge, 1 point, calculate magnitude of B, and we assume that V and B are perpendicular, so V is to the right and B is into the page. In general, there may be some angle between them, and you remember that when V is in direction of the field or in opposite direction, so when angle is 0 or 180 degrees, the force is 0. So a charged particle doesn't experience a magnetic force when particle is moving in direction or parallel to the magnetic field. So B becomes 6.9 times 10 to negative 16 divided by 1.6 times 10 to negative 19. V is 2.7 times 10 to the power of 7, and it becomes 1.6 times 10 to negative 4 Teslas. So two significant figures. The next. The electric and magnetic fields in F remain unchanged. Given a brief explanation in each case, compare qualitatively the deflection of the electron in F with that of an electron traveling at greater initial speed. So for the previous situation, there is electric for electron. It's there is the electric force, which is what elementary charge in general. It's just charge and electric field, and it's upwards, and magnetic force it's charge for electron, elementary charge, velocity, and v. And if it's also electron but with greater speed, you can see that all other parameters are the same, but v increases, so magnetic force increases, hence deflection downwards. The next, a proton having the same speed. Proton has the same charge by magnitude, but proton is positively charged, and in general electric force it's a vector and charged multiplied by electric field strength, and this value is will be with opposite sign, so vector will be in opposite direction. Or if we consider our plates, electric force will be downwards. Why? Because proton will be attracted by a negatively charged plate. So electric force will be in opposite direction, it will be downwards. And also magnetic force also will be in opposite direction, because for proton we will use the left hand palm rule to find direction instead of the right hand palm rule. And it's because also VB in general it's a cross product of two vectors, and the result is vector, and since it will be multiplied by a value with opposite sign, so vector of the force will be also in opposite direction. Hence both forces reversed in direction but not changed in magnitude, hence undeflected. And an alpha particle having the same speed. What is an alpha particle? It's a helium nucleus. It has positive charge, and by magnitude it's 4 elementary charges, and positively charged, so it will be undeflected due to it's positively charged, not negatively, but it will be same as for proton, so it will be undeflected. And according to 4e, we can see that charge and both forces will be increased by the same factor, hence it will be undeflected. Or actually for alpha particle, if we compare with the electron, forces will be increased by the same factor, and it's by factor of not y4. Helium it's 2, 4, it's mass number 4, it's 2e. It's 2e, not 4e. But it doesn't matter. And so both forces will be reversed and increased, and magnitudes will be increased by the same factor. So it will be undeflected. And that's all for this question.